Hello there, environmental science class. Just finished going over chapter 9, non-renewable energy sources, and I'm getting used to talking to a phone. It's kind of hard to sit here and talk to a phone, but hopefully I'll get better at it as time goes by. But when you think about chapter 9, we're going to discuss sources of energy and how they're efficient and feasible in various forms of other energy. Now, the energy source that most commonly used by industrial nations like the United States are non-renewable fossil fuels. Now remember, non-renewable fossil fuels are bad for the environment, so we're trying to find new ways that we can produce electricity. Now, fossil fuels still remain, are parts of the remaining of once living dead organisms that were preserved and altered as a result of geological forces. So things that lived a long time ago got buried and compressed, and they turned into coal, oil, and natural gas. Those are the main three. Now, the extraction and transportation and processing of each fuel type has its own environmental issues. Like, for example, coal. Coal is a very efficient source of fuel, but the mining disrupts the landscape. Oil extraction causes less damage and is more concentrated energy source. Now, natural gas is the least disruptive and causes the least amount of air pollution. Now, nuclear energy. Nuclear energy is energy released from radioactive isotopes of some atoms which have unstable and, they just decompose. Nuclei decomposes. Now, I'm not really good with the two materials that are commonly used in nuclear reactions. I've been having trouble remembering it, so I've made some mental notes out of my students. So, Mackenzie, now which one were you supposed to remember? There was
uranium-235.
Uranium-235. That one's always a hard one to remember. And there was one more, and Caleb, what was that other one?
Plutonium-239.
Plutonium-239. Now, my own boy back here in the back, Larry Ree, first name and the last name with the last name, first name. Pretty neat idea. He's a little worried that we're going to be doing a lot of chemistry in here, which we're not. As long as he can remember uranium-235 and plutonium-239, well, I'm working at it. I'm working. All right, we're getting there. But this nuclear energy is created in a nuclear reactor. Now, a lot of you have no idea what a nuclear reactor is, so we'll be learning something about that. But basically, it's to control the chain reaction and the splitting of nuclei, which release the energy until the fuel is spent. Now, uranium-235 is commonly used in reactors to heat water to produce steam that generates electricity, which is good for us. Now, there are several different types of reactors. There's breeder reactors, pressurized water reactors, and there was one more, let me think here for a second, gas-cooled reactors and boiling water reactors. Now, all types contain a core of fuel, and they have a moderator to control the rate that the reaction takes place, and they have cooling mechanisms to prevent them from overheating. And just for future reference, if you ever build a nuclear reactor, please do not build it on or anywhere near a fault line that will end up in big problems if there is an earthquake. Now, nuclear power currently produces about 16% of the electrical energy consumed worldwide, and it is on the increase due to the rise of energy prices and concerns over carbon emissions. But that's all I have for you for just a little brief intro into chapter 9. I hope that you can read through this chapter and learn a little bit, and we'll get over the concepts here in a few days. Talk to you then.